Facebook, YouTube, and LinkedIn. Please leave your comments, questions, feedback in the comments section. We will get to all those at the end, at the Q&A session at the end of today's session, and take all the questions. That's what I mean. And those who are joining in on Zoom, please ask your questions, comments in the chat section. With that, let's begin today's session. Today, the topic that we have is an exciting one and a very apt one. It's role of data engineering in AI. In AI, while we focus on algorithms and modeling, data engineering too plays a very important role. Data engineering enables to move AI to production and out to practical use. Okay, a little confusing, but our speaker today is a very friendly speaker who will explain each and every points that he has already started explaining before the session even started. So about about Arun Kumar Nair, his background, he has 19 years of IT experience in big data analytics, data visualization, data warehouse, and cloud and application projects. He was in US and Middle East for almost 2 years. And he has hands-on technical expertise, architecture, and provided solutions. He worked for clients like Rocky Mountain, Navtac, Nokia, M&T Bank, Weight Watchers, Hollywood Media, SHRM USA. He's passionate about analytic vertical, because he can drive emerging big data technology and align it with business growth. And coming to his personal likes and dislikes, he likes to go on road trips in India. He likes to visit sanctuary, observe nature, and go fishing. And above and beyond, he is a very friendly person that I have interacted in the last week. So thank you so much, Arun, for joining us. Over to you.
Thank you, Julan Chatterjee. And I should let all the participants know, like, we had a lot of interaction, and it was thanks to Julan's late night calls. There were some, last minute glitches which we had, and Julan managed to fix it. And I saw that she was working very hard to make this event happen. It was because of her efforts and proactive interest that she showed that this whole session has happened. Otherwise, we would have missed each other for various communication reasons, especially from my end, and it wouldn't have happened. So once again, thanks to you, Julan, and also thanks to all your participants for joining in for this session. You can stop me at any point of time to ask a question. And
I want to stop you right now, saying a big thank you, Arun. Thank you.
Thank you.
Please go ahead. Yeah. Thank you.
So, just let me tell you that a lot of things has been happening in the world today, especially with COVID coming in. Things have got disrupted. This is unimaginable times. We never thought that we will be locked down home. The entire world will be locked by a small virus, which is just, you can't even see it. And that is the strength of the nature and God, the super nature. You can't just beat it. And how much ever money or power or muscle power you have, you are actually helpless in front of nature for all reasons, So, and also it has brought the world together. A lot of disruption has happened. A lot of lives have lost, careers are being lost, but I'm sure in the end we will all come stronger. Okay, so with that belief, we take this forward, and I welcome all of you. We should work together to achieve our goals. So that is the idea. Now, when we talk about artificial intelligence, data engineering, let me tell you that these are all keywords or jargons which are there to attract us. Had this session been written as role of maths in AI in life, nobody would have joined, So primarily, if you see most of these technologies, algorithms, we all know and we have been using it day in and day out, and we just don't know that this is what artificial intelligence is. And for that matter, let me tell you that when we use this word artificial intelligence, I feel it is just a, a spelling mistake that has happened, or a misname. You have named something wrongly, because if you look at it, I think we haven't even reached the intelligence of an ant to claim ourselves to be artificial intelligence. So this is my belief, which I say. What you're seeing around you, robots walking, intelligence, these are all basically mathematical equations. And all of this has started happening because of the conversions of large computers which can compute things faster, and because of data which is there available. And also surely a lot of scientists and researchers who have put in their great efforts to build these technologies. So no doubt, the credit goes to them, the innovation, all of us there. But at the same time, I just want to put in a caution there. When we think of certain things replacing the human being, yes, it is replacing human beings from a computing standpoint, because the human beings were some of the work which was being done by human beings was always being replaced all through the mankind, whether it is if you start from the earlier days, you know where human effort was there. The human being himself is great at building tools for making life easier. So I would say this whole technology landscape is just another tool that will help us make our life easier, and it will free us to do much better things. Makes sense, everyone? I hope this is a great start. Any questions here? You can put it in the chat or unmute and tell me.
Yeah, Arun, you can go ahead. They will put it,
Okay,
or else we'll have the question answer session at the
question.
end. Yeah.
Okay, thank you. So,
Thank you.
having said that, I'm actually diving a little bit deeper into technology now. What I'm showing here on my screen is the agenda that we are going to cover, the roles and skills that are there in AI, and then what kind of tools and technologies are used, which is data processing, data storage, ELT, ETL. Okay, a lot of it is jargons that you are going to see, and feel free to ask me these jargons. Okay, and I will start explaining to you. So what we are going to look here is the evolution, roles and skills required, what is data processing, what is data storage, ethics in AI and data. I'll cover certain pieces of ethics, discuss with you in detail some of those examples. Then what is machine learning? What do you mean by machine learning? Do machines really learn? And what is deep learning? Then CICD for deep learning. Okay, so these are some of the things that we will be talking about. Okay, so friends, like I told you in the start, I like to interact, and I believe that if you ask me questions and if you keep it interactive, it will be much more easier for us to learn certain topics rather than it being a monologue. So uh, uh, I'll start with a question that was there, that had come in from Raj. His question was around what is data engineering, what is AI, what is the role of data engineering. That was one of the questions that was there. And then Deepa, she asked me, how do you start learning AI? Okay, what are the skills that are required in AI? And then we had Srini, who said that keep it technical, wherein the folks can come to know the different technologies, the landscape, what is the return on investment. Okay, so we will be covering all of this. So let me start with one simple thing, that is with regards to what is artificial intelligence. Okay, so like I said, there is when you look at artificial intelligence, what primarily anything is doing is that uh, we have a set of data here. That is what I'm drawing on the screen. You all can see this is a set of data, and we are running some equations around this data. and that will give us some meaning out of this data. So it could be very simple, as for example, you're in California state, and you want to house on buy a house in Hollywood Boulevard, okay, that is or maybe in Long Island, okay. And what you do is first you go around all those houses in those areas, and you identify the size of your house that you want, okay. The size of your house may be 2000 square feet with a garden, okay. So that is the house that you're looking at, and you will ask the residents or the people around there, what is the price of the house, okay. So what do? You go and ask those people what is the price of the house, and then they tell you that the price of that house is $5,000. Someone tells you $6,000, and then someone tells you again 7,000. So you collect all this data of prices, put it as a data set, and then what you do, you what do you do before you purchase a house after collecting all this data? You go and find the average, isn't it? You all agree? You go and find the average price of these houses, correct? And then you come up to a number, and that number will be around $5,500. And then you realize that houses in this area, which is around 1,000 square feet, is going to cost you $5,500. How did you come to this answer? You came to this answer by using a very simple equation called as average, or called as the mean. You all agree? Now, this is what is you just did with the data. You use this data and you got some intelligence out of it. And what the intelligence you got is the price of the house. Now, this is the simplest form of AI that we have done. Now, what we can do is you can make this, okay. So some of the houses which are there, which are priced at around $3,000, or some which are priced at $5,000, or which are priced at $6,000, okay. There are different prices that are there. If they are within the range, it is easy for you to identify and say, okay, this is the price of the house, and they will be in the range that you look. But if the range is wider, okay, for example, the price of the houses start from $3,000 going up to $15,000, it will be very difficult for you to make a prediction, okay. Then the average may not work. What you may try to do is you may try to think of a better equation to come up with an answer. So when you say artificial intelligence, okay, what are we doing? You're collecting data here, right? This is the data that you have. I'm putting it here as D. You're running an equation, okay, that understand this data, and what you get is answers over here, correct? So what does artificial intelligence means? Artificial intelligence is very simple. It means you have a set of data, you have an equation, okay, and that equation understands the data, and it gives you an answer. So the next time you want to find an answer, what do? You provide the data to that equation, and he gives you an answer. Makes sense? Like in this case of buying the house, what you did, you went around, collected all data of the housing prices, created a mean out of it, and then you found the answer of the house. Now you can put in more variables or more parameters when I'm trying to think of the price of the house. Like for example, I just said that it should be the size of the house should be 1,000 square feet, right? So when it is 1,000 square feet, I can add few more parameters. It should have a garden or a lawn. It should have a swimming pool. So that is the third parameter. And the fourth one is it should have 2 car garages, right? And now you will start again putting weights for these parameters, and you will build a new equation that will give you an answer. So when we talk about machine learning, artificial intelligence, okay, what is it doing primarily? Can you give me this answer, one of you? What is it doing primarily? Okay, I see somebody who's answered. Let me just check. Anyone would like to unmute and just give an answer?
Yeah, it is kind of relating the variables and then trying to arrive at a relationship which can be replicated.
Absolutely. So it is creating a relationship using the equation. So when you say artificial intelligence, it is a combination of data, it is a combination of some equation that you have, okay, and then computing. All of this is what is bringing in intelligence. And if you see, you have seen these kind of intelligent operations even when you were in school or colleges. You were using different types of calculators, scientific calculators, to come and arrive at answers. Okay, so all these things which are there today, they all have been around, and there have been a lot of artificial intelligence that has been happening. Only thing is, now with the advent of all these technologies, things have gone much more sophisticated, and they all came together. It is not that someone started out saying, okay, let me build an artificial intelligence software. No, it didn't happen like that. What happened was, we had the Google search engines, we had lots of data, we had social media come in, we had cloud computing there. The algorithms were there since the start of the century, about 200, 300 years ago. Okay, all of this culminated together. Parallel processing came in through Hadoop, and then what you see is a much more better way of doing things. So if you see, artificial intelligence is all about data, it is all about cloud computing, and it is all about human creativity also. Okay, so with this, I am starting my topic, what is artificial intelligence. I hope you all got a sense of what it is. It's very simple. And let me tell you, if you have children at home and they are studying in grade 4 to grade 10, or even grade 11, 12, all of them are actually working on algorithms which they will use in these tools. And who are the best people equipped to get into this area? It is these children or the young people, because they are very familiar with the technology. We all learned this technology when we were doing our grade 5, grade 6. We learned Pythagoras theorems, we learned what linear regression is, we learned a lot of things, and you will find all of them getting applied in this place. When we learned in our schools and colleges, we really didn't know the applications, but this is one topic. If you start learning, you will see, oh, this is something which I learned in grade 4, this is something which I learned in grade 5. You will relive your childhood memories. Okay, so going ahead, I'll just move to the next slide. So what are the tools and technologies which you can see here? So what is the role of a data engineer? Since this topic was more around data engineers, let me tell you, data science, artificial intelligence, these are all team sports. You need all kinds of people to work on these technologies. You need domain experts, you need people who are business stakeholders, you need critical thinking. Okay, you can see here right at the bottom of my slide, that is the section that I'm talking about. So here you can see, this is critical thinking, business intelligence, communications, all of this. They play a big role in your AI. Okay, and then you have stats and maths. Okay, without business, because without critical thinking, without creativity, these are just technologies. It really doesn't matter. And a lot of these things you can actually start doing it in Excel. Okay, if you have an Excel sheet, you can start applying a lot of these technologies and make business. So this is business stakeholders. The other important people who come in is this term called as data scientists. Let me tell you, today technology has democratized this world. There is no one, you don't need a PhD, or you don't need hardcore mathematical backgrounds to do it. A certain amount of conceptual understanding of these topics will help you do what data scientists can do. So there were days earlier when technology was just started in the early 70s and 80s and 90s also, and of course in 2000. Most of these technologies, or the high end statistical work, was being done in the life science companies, and they had a lot of money, they had a lot of big computers, and the software which were very expensive, and they were doing this deep dive computing work. But now with open source technology, it has become very democratized. Someone who has passion and a lot of uh, uh, desire and dedication can start learning this technology. So the primary skills you need here is again stats, a little bit of maths, some amount of creativity, then know how modeling is done. Then you learn these two simple languages. I would suggest you go in for Python. This is the easiest language, most popular in the data science community. Okay, so this is data scientist, and then there is hardcore engineering work. Okay, that comes in from software engineering. So there is plenty of scope if you have done some kind of programming. Let me tell you, the 80% of the work is still cleaning of data. Okay, and it is only 20% of the time that a data scientist does is model building. So even today, cleaning of data, understanding the data, identifying the data sources, these are all very, very important. And if you already know SQL databases, you have an edge over other people, to get into these technologies. Okay. And now let's move on here to the next one, the role of the team members. Okay, I just explained that. So I will move here from here to data engineer does hardcore data engineering work. Data scientist does the build modeling. Business stakeholders do the uh, bring in the creativity into this space. So ethics in AI is very important because see, when you talk about AI, they're just data. You will see a lot of biases getting built in by this data because they really don't know. They don't have their own consciousness or intelligence. It is how you program them that they start learning. Over a period of time, even small biases in this data will move this AI tool into a particular direction. So one of the examples of this was, Amazon had built in a tool, AI recruitment tool, and that AI recruitment tool started showing a bias against the woman. It's very simple. I'd like one of you to just tell me, it's pure common sense why it happened. Just can you guess why do you think this AI tool that they built started showing a bias against women? Any reason you can tell me? One of you would like to take a guess here? Creative guess? Why do you think Amazon's AI tool showed a bias against women? Okay, I think I have not seen any answer. You can just unmute and answer here also. Yes, someone would like to answer. Okay, I do not see any answer here. Okay, so one of the reasons that it happened was, very clearly, if you see even today, the percentage of women in the workforce is less. There are more number of men who are there in the workforce. That is one reason. Okay, and there are certain keywords which are there in the existing data that shows that you know things that men do seem to be more suitable for the work, and there are things that a woman do which seem to be not suitable for work. So that is what that data reflected. It had nothing to do with the AI tool. It was whole that our society had data that was tuned in that manner. For example, let me tell you, like, the number one thing is, even if you collect if you go to a company and you collect about 100 people, you will see that about 30% are women, and around uh, uh, 60 to 70% are men. Again, it changes from industry to industry. Specifically, I'm saying about some IT industry, or even if you go to a manufacturing industry, you will see more predominant of men there. So if you are going to collect data, you will see that there is more data available for men. Okay, and there is a lesser amount of data that is available for women. So what happened when they collected this data and fed it into the AI tool? It clearly showed a bias against women because the data itself was like that. It had nothing to do with the AI tool. What the engineers should have done is they should have balanced the data right in the beginning. So if they had balanced the data, or made some changes into the data, they could have reduced the bias that was there against the movement. This was one example. The second example is with Cambridge Analytica. I'm sure many of you are familiar with how Cambridge Analytica was trying to use tools, technologies, individuals private profile to feed in information about a particular candidate or a particular party, and help them win. So that was an example of how democracy or certain things which are unexplainable in the society, it's very difficult for me to tell, because some of them may be for it or some of them may be against it. But Cambridge Analytica did play a major role by taking millions of personalized information. Now if you look at Facebook today, it has more than 1 billion people on Facebook. Okay, approximately. That is like the one of the biggest congregation of humans who are there on a particular platform. And here is a one company who had access to that kind of data, and it was running analytics over it. You can do a lot of things that may be unethical. You could use money power, you could use AI to change the tide in your favor. So these are two classic examples. There are many more examples where the AI tools show specific bias against a particular community, a particular gender. So we have to be guard ourselves against these biases, so that life becomes easier, not difficult, because of these technologies. Okay, any questions here? I'll just pause for a minute and move it. Do you have a question so far? Looks interesting, all of you? Gets you exciting to learn more about AI now from here on?
Yeah,
Okay.
it is very, very interesting because it should the technology should become more of an equalizer, and it should create a level playing field rather than creating biases. And
Correct, Srini.
fortunately, we have the information backbone to identify such trends. When Cambridge Analytica did that, we were able to find it out. Okay.
Correct.
So
Correct.
this is something that people are able to find out what is right, what is wrong, and how to set it right.
Very true.
So
Absolutely.
people no longer need to be in the dark, and they can get ready to act.
Yes. So technology is the great equalizer. In fact, you can use technology to make things better. And like Srini just said, this data is available. You can always pinpoint and make those changes. And you will see today, the COVID. Okay, you must have seen a lot of decisions were being taken by these AI tools. So it's saving life. Okay, a lot of work that is happening in finding the vaccine, okay, is being shortened because of these AI tools. So there were times in when the Spanish flu happened, or even before that, many of the pandemics that happened, to produce a vaccine, it used to take like decades. And today, we are talking about months and years. This is unbelievable. So this is where technology is. Technology will, we have to do it for the good of the society, the good of the people. That is where we are going to try to use this technology. Okay. So here, some of the things which I just wanted to cover from a technical point, types of data and storage. So these are the different tools and technologies that are being used in AI with regards to storage. I'm sure many of you may be familiar. You can store it over a database, as a file on the disk. Okay. And then what you do is you load all this data into the random access memory of a computer. So there is CPU. CPU cannot process a lot of data. It has limitations. That is where you have a GPU, that is a graphical processing unit. One of the popular GPUs are from NVIDIA. And the other technology that is similar to the GPU is called as a TPU, tensor processing unit, from Google. Okay, so these are primary technologies, the GPU and the TPUs, that are helping you to run self-driving cars. Okay, so these are the keywords which you can keep in mind, which is helping you build AI tools and technologies. Okay. So, how do you, what is a traditional ELT? Okay. Sorry, this should have been named as ETL. Okay, I'll just make a correction here. Sorry. So this is known as ETL. Okay. What ETL stands for is extract, load, and transform. Okay. It is a jargon. I deliberately put this jargon here so that some of you who may enter this field, it is good to know the jargons. So what ETL basically means: extract the data, transform the data, and load the data. Okay, so this whole ETL technology has been there in software engineering for more than now like 30 years. Okay, so what you do is you have a data source and you extract data from there, and then you get it into a staging area. Staging area is a temporary area, and the various sources of data, like data coming from Twitter, data coming in from Facebook, data coming in from your pension systems, from your ERP systems, all different forms of data. Okay, you get it into a central temporary repository, and all of this data is moved into a central location. So this is known as a data warehouse, and it is using this ETL technology to build the data warehouses. So what they mean is ETL is extract here. That is what is happening. Transform, you transform this data because there are some data that you don't need, some data that you want to combine. That is the transformation, and then you load this data into a database. So this is traditional one. It's been around in most of the companies. The new way of doing this is called as ELT. That is what we will see in the next slide. Okay, sorry, I moved aside ahead. So this was supposed to be ETL. Okay, so this was supposed to be ETL, and this is what is traditional, and then this is ELT. Okay, so there was a glitch here. Sorry for that. Yeah, so this is ELT. What it does is, when you had ETL systems, it took a long time to build those systems. So instead of that, what you do is you have various sources of data which has structured and unstructured data, and then you use this. This is extraction that is happening. Then you load this data. So this loading is what is happening here. So why do you load this data? Because nowadays, spending 6 months to build a data warehouse, build a system that will extract and then transform and then load data, people don't have that kind of time to wait for you. So what do? You first extract, load within 1 or 2 days, and then you start transforming. Okay, so this areas are known as data lake. Why do you call it as a data lake? Data lake, the instead of a data warehouse, you are calling it as a data lake, because lake is a place where you can pour in water from all different areas. Okay, so it is like a reservoir of data. Okay, reservoir or a dam that collects data from all sources, and then you extract intelligence from this data. So that is what is this term called as ELT. The transformation is in the end, because you transform it later. First you extract and load, because you need to do this fast, is because the business is waiting with the data. If you spend 6 months to just extract, to build the system that will extract the data, you are actually losing 6 months of valuable data. So that is why the whole paradigm has changed. Okay, so this is what it is. This is all part of data engineering, friends. I'm showing you things which, it is not just to do with algorithms or model building or stats. There is a lot of data cleaning that happens. There is a lot of extraction of data happens. This is all part of data engineering. Answers your question, Raj? You had a question. I just trying to answer it as we go along the slides.
Yeah, it is very clear. Now we are able to see the components of it. Okay.
Yes, thank you.
What are the building blocks? We are able to clearly understand. You can proceed. Thank you.
Thank you. it helps, that I know there is someone who's very cleanly listening me. So here we can see, the typical data pipes. Now, why are we calling these as data pipes? Because they are the pipelines that are going to get you the data into your model building area. Okay, so you have user data, you have data that is being collected, then you extract the data, you process the data, and then this is the cooked data. Okay, so this is a typical pipeline. You have many technologies that will help you build this pipeline. Apache Kafka is one of those technologies. Okay, so there is a Logstash. Okay, so and then also you can use Python. So here what you can see is a Python stack of technology that is helping you to build the data pipes. So let's move ahead from here. So we saw what a data pipe is. So you can see here some examples of Python. You are using basic Python to build data pipes. You are filtering the data, pre-processing, joining, sorting, and storing the data in a persistent environment. And your data pipes now can have two different pipes. Now this is one streaming pipe, okay, and this is what is there is the raw batch processing pipe. Now this is the source, and these are the pipes. So this is pipe number one, okay, and this is pipe number two, okay, where you have two different pipes. Now where is streaming pipe used? Okay, now just imagine, you are standing at a a, a, a city a downtown city, and you want to move to your house from your workplace, and you have Uber app with you, and you are trying to book the car. So what happens is, in that particular region, okay, there are about, for example, around 200 cars, okay, and there are around 150 odd passengers who want to book the car. Okay, so if you had used a database operation wherein you have this particular customer that is taking the Uber and trying to uh, book a car. If this whole operation was to be done by one individual, it will you click your position, and then it goes to the database, hits the database, and tries to find how many passengers, so how many people are there who want to how many cars are available who are willing to go to this particular location that you want to go. Imagine, if all of this takes time. Okay, there is a complex thing that is happening in the background when Uber is trying to book a car for you. For you, it may appear that it is happening in a few milliseconds. So there is a complex set of technologies that are running in the background. Just imagine the complexity. You have, if you didn't have Uber to book a car, you had to go onto the street, hunt for a taxi, okay, ask him, are you willing to go to a particular location, negotiate the price, and then book the car. So it used to take you about at least half an hour or an hour to book the car. If it was on a telephone, it would have still taken you 15 to 20 minutes. Now this whole operation of 15 to 20 minutes, Uber has been able to do it within a few minutes or even seconds sometimes. Okay, so how does it happen? It happens because of streaming data. Because a lot of analysis it is doing is while the data is in motion. So this streaming data is also called as data in motion. While the data is moving through the network or through the data pipes, the analysis is happening, and it is trying to find answers for you. Just imagine another example. Suppose somebody swipes a credit card, okay, and there is a fraud when it happens. Do you want the bank to come up and tell you about the fraud after 2 days or 3 days? Definitely no. Correct? You want it to be known about the fraud as soon as possible. And you must have seen in earlier days, if you have experienced such kind of a situation, you will see it used to take about a day or more than a day to understand a fraud had happened. And you would come to know about the fraud only after the transactions had happened, and you have a look at your messages or at the summary statements that you come to know a fraud has happened. Now, with use of streaming data technology, with use of streaming data pipes, all this is possible within milliseconds. Okay, so that is what you can see, streaming data, and then you have raw data here. Okay, this is more like batch processing, traditional one. And that is how the new age technologies are working. This is all data engineering, friends. Okay, so I'm touching upon more about data engineering because I'm sure many of you are familiar with how AI works, how algorithms work, but I'm trying to cover up a separate aspect of technology here. So overall, how do you do a machine learning workflow? So these are the workflows that you have when you do machine learning. Okay, you understand the business need, and then you build a viable product. Okay, so this is where the real work happens. Okay, you get the data, prepare the data, do model building, evaluate. So these are all jargons. Let me tell you, what you are trying to do is build an equation. You remember the earlier example I spoke about? Okay, you are trying to predict the price of a house. Get the data of the house, do a mean, and it gives you an answer. So what you're doing is just more complex equations to get an answer, and then finally you productionize, deploy it. Okay, so this is the typical life cycle that you have in uh, in this area. Okay, so we have another 11 minutes to go. I will quickly move over the slides, and then the last 7 to 8 minutes I'll wait for questions. That's right, Julian, right? That's the plan, isn't it? You can just put it on the chat.
Yes, yes, please.
Thank
Yeah.
you. So here what you see is a typical example of a machine learning data pipeline. Okay, you have loading data, splitting the data, splitting the data into training and validation, and then evaluation, and then building the deployment packages. And this is something about deep learning. Okay, so what is machine learning? Machine learning is creating equations. Okay, where there is where a data engineer plays a role for deciding the equations. The data scientists, all of that is part of machine learning. A lot of equations like the naive Bayes equation, linear equation. The naive Bayes equation has been around since the 18th century. Okay, so that is machine learning. It is a little bit less complex. Deep learning is far more complex. It is using neural networks. That is, it is trying to mimic how humans think. Okay, and that is how it is getting implemented. So this is the technology stack from a data engineering standpoint. Okay, the different frameworks that you use, like TensorFlow, Keras. Then you create data sets. Okay, do hyperparameter tuning. Okay, monitoring. So these are all how you actually build a AI tool. So some of the good examples of AI tool is, if you go into Facebook, the automatic, when you upload a photo, it detects your face and gives you a name. So it is known as object identification. So it is using neural networks in the background. It is also known as deep learning. What is it doing? When you say deep, it is just building more complex equations for you. So when you are trying to match two faces, okay, when you're trying to match your face with the face of the photo that is there, that is deep learning that is happening, also known as neural network. And that whole process is known as object identification. Okay, and this is CICD, that is continuous integration and continuous deployment, that happens in these deep learning projects. So you are using DevOps here, wherein you have CICD pipelines, that is like Travis, Jenkins. You deploy the file. This is kind of automating the entire artificial intelligence life cycle. Okay, along automating means starting from building the configuration management systems to deployment in the production is being automated. That is what you can see here. And this is anatomy of a chatbot, how chatbots work. Okay, so you have various kinds of services and APIs that helps you to build chatbot. Okay, one of the very difficult technologies is understanding language. Okay, and trying to converse with somebody in that language. But a lot of softwares have started actually conversing using chatbots, and do human like conversations. Okay, so this is what it is. Okay, I think we have almost come to the last slide. Okay, so this, if you're trying to build a predictive maintenance software, wherein you want to predict in advance if a particular machine is going to fail, or if the lift is going to go down, something that you want to predict even before it happens. Okay, so this is the architecture for the predictive maintenance. Okay, you can see a lot of data engineering is what is happening along with the modeling piece. The modeling piece is something that happens separate, but this is the deployment area, various technologies that are being used to build this software. Okay, so where do we use it? You will use it in almost every space of your life, right from now. This is for marketing. I've just put here from the marketing field, optimizing products, acquiring customers, retaining customers, doing sentiment analysis, and marketing analytics. Okay, so this is my session on data engineering, role of data engineering in AI. We have another 7 minutes to go. I hope you all are finding it exciting and eager to jump into this field. I'm open for questions, friends.
Yeah, Arun and Julian, it was a very interesting talk, but we must definitely get a copy of this, the slides that he showed, because in consideration of the time available, we could not even read the blocks very carefully. Julian kindly sent a copy of it so that we can complete the learning part of it. And Arun, it was,
Sure.
yeah.
Sure, I will.
Yeah, Arun, it was a wonderful talk. It was like listening to somebody who is your neighbor, like who's such a friendly guy who can talk without any pretensions in a very simple to relate way. Somebody from a neighbor you can learn across when you're standing in the veranda. You ask him some questions, the guy tells. It was very simple and easy to digest. We wish we had a little more time on the slides, but definitely once we get it, we can pour over them and understand further our understanding. Very interesting and nice. Thank you.
Thank you. It has motivated me. And Srini, you are a magnificent CEO, and looking forward to more questions from you.
No, it's definitely, it's a great. Yeah, please go ahead, Nagendra. It's a great, wonderful session actually, and the way that you explained and the keen enthusiasm that you were able to invoke from us. Thank you so much. Yeah, Nagendra, please go ahead.
Yeah, sure. Thank you, Srini. Yeah, Arun. Yeah, thank you so much for this wonderful presentation. I have few questions. Like, if AI, when we see like self-driven cars, right? So where it can watch the objects. I mean, that kind of sensors are adapted to the vehicle, and it can it can drive. But as a human, suppose if there is a one position and there are 5 guys attending an interview, right? So if there are 10 similar questions for all the 5 guys, the answers cannot be equally come out of them, right? So some may give out of 10 only 5, some may give 6, 7. Like, so it is the thinking at that time. It involves what they have learned, what they have remembered, and what their emotions, and also in that, that's one example. Okay, so all answers cannot come equally from 5 or 10 different persons. But when it comes to the AI part, the AI has to understand all these 5 or 10 guys' answers, and it has to give an correct 100% answer. Then only it can be a successful product.
Correct.
Am I correct? So if that is the if that is the case, okay, when it is checking all the algorithms and all the algorithms depends on data engineering again. So the transformation or extraction, transformation, loading, right, from the data lake. Okay, so even if that is the part, if we have everything correct or harmonized data, but as a human, right? So even still, it can answer based on the data it has in the database. But when it comes to the touch, taste, feelings and emotions, how does the AI can work going forward?
So you have really hit the target. See, there are limitations. Like I'll just give you some example. Like for example, we are sitting in a party, a couple of friends, and we were supposed to meet at 5, and four of them came at time at 5, and then the fifth one, fifth friend who has to come to the party is late by 20 minutes. Okay, and you make a comment there saying, hey, John, you're very early, correct?
Yeah.
So there is sarcasm in that,
Yes.
and your friend understands that is a sarcasm.
Yeah.
And you all smile and laugh at it. This is something which an AI tool will never be able to figure it out. We are a long way off, because the AI tool is basically computing. He's just, what he's going to do, hey, John, you are very early. What he's going to say, it is a positive sentiment, correct? And he'll be happy, but it's a sarcasm there, right? So there are many things that an AI tool will not be able to do. The human consciousness, intuition. Many times you really don't know if something is going to happen, but your intuition says that it is going to happen. Like making a choice of an idea. It all, those intuition that you see is going to actually take a long time. And look at the self-driving car. They have poured in millions and millions amount of dollars and data to build a self-driving car. It's being on as a project for more than 5 to 6 years, and there has been many mishaps. They have come to a certain amount of accuracy, but if you go to a street which is highly crowded and lot of people and don't have lane markings, those cars may fail. It may succeed in well marked areas, but in some areas it may just not move. Okay. So, so when you look at AI, it is basically computing. So if you go back to our school days, we had a calculator. We put our calculator in the pocket. They told us not to carry calculators into the classrooms, because why? It was going to ease your job. Mentally, our mind is not tuned to do heavy number of computing. Okay. There were days in the 80s and 90s, okay, where one computer used to fill up a room. Today, that same size of computer, you carry it in your pocket. So that is where computing has gone. So anything that needs to be computed, these technologies will move way ahead. Okay. Anything which has love, compassion, heart, I think we are a long way off from that. It is going to take quite a long time to achieve those kind of efficiency levels. Answers your question?
Yes, Arun. Yeah, thank you.
Thank you. Yes. Anyone else has a question for me? Do you have a question?
I don't think there are any questions. If you have, please unmute. And yeah, I just loved the storytelling part of it. When as soon as it comes to AI and things like that, it's technical. But as Raj rightly said, when it comes from a next door neighbor, that it feels like that, then definitely the power to take in always increases. So thank you so much, Arun, for that candid, giving real-time experiences, which always gets in our memory and lives in our memory for a long time. So thank you so much for taking the time out.
Jilan, sorry to Jilan Nagendra here. Arun, I have one more question, Arun, if you have time.
Yes,
when we are talking about data engineering, we
yes,
came across ETL, extraction, transformation, and load. When it came to Databricks, okay, when I think the pattern has changed to ELT, extraction, load, and transform. I see the Databricks data lake concept is something like a centralized product. Okay, you bring everything and keep it there, and then distribute to the targets, right? So whether the centralized way of methodology is good for AI, or decentralized methodology is good for AI?
It is a little difficult question to answer because both will work, depends upon the business use case. There will be situations where you need centralized data, very small data, especially when you are using IoT sensors or concepts like edge computing. But at the same time, there will be situations where you want to build a data lake and put all the data, dump it into a central location. So it has to be looked at a case to case basis. One of the things why data lake has become so popular is because with Hadoop coming in and parallel processing and parallel computing, the cost of storage has come down. Okay. So that is one of the reasons you will see that there are terabytes and petabytes of data people are willing to store. Also with cloud computing, S3, all these storage devices, you can actually store all these on parallel computing systems. So because of technology, storage cost has gone down, so people don't mind storing data as data lakes.
Okay.
Yeah.
Thank you, Arun.
Thank you, Nagendra. Okay. Fantastic. It was a great team of participants, Deepa, Nagendra, Sirisha, Suryakala, and of course, Srini and Julan. It has been amazing talking to each one of you. Thank you for this opportunity. Have a great day ahead.
Absolutely. Thank you so much, Arun. And
Thank you.
yeah, so after today's session, we have another session tomorrow, another amazing one with emotional intelligence leads to resilience. So if you are interested, or we have heard a lot about emotional intelligence, so to know more about it and to develop that resilience, please join us tomorrow at 12 to 1 p.m. EST Eastern Time. And have a wonderful day ahead, who are joined in from US and other countries, and have a very good night for Arun and others who have joined.
Yeah, just want to add one more thing. We had a youth session on Friday. You want to tell about that, Chulu?
Yeah, of course. I'm always excited about that youth session, and to some extent, we have taken it as our own pride. These youths who have joined in, and we have this "Let Us Talk It" youth series, and we will be having this Friday as well from 12 to 1 p.m. EST, and the topic is appreciation from outside versus self-contentment. Lot of areas when we were brainstorming, when the youths were brainstorming, it's a fascinating topic. Trust me, just join, ask your kids, youths, teenagers, whoever it is to join. You will benefit, you will learn something new. Trust me. So we have that youth session also on Friday from 12 to 1 p.m. EST. Thank you, Srini, for reminding that. Yeah, and with that, we end our session today. Thank you so much, everybody, for joining in, and have a wonderful day. Bye.
Bye.
Bye.